Let's talk about the Lagrange multipliers in this lecture. Lagrange multiplier is a method when we want to maximize or minimize a function that is subject to a constraint. Suppose we have a two-variable function, f of x and y, and we want to maximize and minimize a function subject to a constraint, g of x and y equals to a constant k. The graph here will help us to interpret what we want to find and the Lagrange multiplier method. This graph shows the level curves of the function at several levels. It shows the level curves of the function when the function equals to 7, 8, 9, 10, and 11. So this function will have multiple level curves, but the constraint g of x and y equals to k, that is also a function of two variables, but it is subject to the constraint. That means we only take the curve of the function when that equals to the level k. So we will only draw the level curve of the function when this function equals to k. Then what we want to find is the maximum values of f that is intersect with this level curve. We notice that the constraint g of x and y equals to k has several intersection points with the function f of x and y. Here's an intersection. Here's also an intersection. Here's an intersection. Here, 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 and here. At this intersection point, the value of the function is 7. Same thing for this intersection point. And the value of f at these two intersection points is 8. The value of f at these two intersection points is 9. And the value of f at this intersection point is 10. So the point we want is the point that gives the maximum or the minimum value of the function, which is this point here. And we can notice that at the maximum or the minimum point, the level curves of the two functions, they just touch each other. That means they have the common tangent line, or in other words, the normal lines at this point is parallel. So that means suppose this is gradient of f at this point. And gradient of g at this point also points in the same direction. So, from the graph, we get that at the maximum and the minimum, the gradient of f at the point x0 and y0 is parallel to gradient of g. In other words, in terms of vector, it will be a scalar multiple of gradient of g at the same point, x0 and y0. And we are going to call this proportionality, lambda, the Lagrange multiplier. Similarly, when we have a function of three variables, suppose we want to find the maximum and the minimum values of f of x, y, and z, subject to the constraint g of x, y, and z equals to the constant k. Then we use the same idea. The gradient of f at the maximum or the minimum should be parallel to the gradient of g at the same point. So we can rewrite that as this vector is some constant multiple of this vector. And the method of Lagrange multiplier is using this equation and the constraint g of x, y, and z equals to k to find the point x, y, and z that give us the maximum values of f. So from these two equations, in total we have 4 equations and 4 unknowns. Because the first equation, that is a vector equation, so we can have an equation for the x component, an equation for the y component, and another equation for the z component. With the equation of the constraint, we have 4 equations, and the 4 unknowns are x, y, and z, and also the Lagrange multiplier, lambda. And since we have 4 equations with 4 unknowns, so we should be able to solve for the 4 unknowns. And after finding the x, y, and z that satisfy these 4 equations, we can substitute them back to our function f of x, y, and z. Then compare the values of f. The largest value would be the maximum value of f subject to the constraint g of x, y, z equals to k. And the minimum value would be the minimum value of f subject to the same constraint. And that is the idea of method of Lagrange multiplier. In the next lecture, we are going to look at 2 examples using method of Lagrange multiplier.